Okay, now we're ready to start working on two-dimensional problems since everything in physics involves more than just left, right, and up and down. Sometimes you've got to combine the two. And what we need a lot of practice on are vectors. And you've probably seen these before in maybe geometry class, where you can represent a number and a direction by the length of an arrow. So this problem says an airplane is traveling 785 kilometers per hour in a direction 38.5 degrees west of north. Find the components of the velocity in each of those directions. How far north and west will it go after 3 hours? All right, so this is our representation of where the plane's actually going. It's moving in this direction. However, if you want to, you can really break it down. It's sort of like the plane is moving north this fast. So I'm going to call this velocity in the y direction, or velocity in the north direction. And the plane is also moving this fast to the west. Notice that if you put the velocity in the y and the velocity in the x together, you get the total velocity, the purple one over here, v. All right, so we have to break it down into these two separate things, how fast you're going north and how fast you're going west. And in order to do that, you're going to need a little bit of trig. So there's only two trig functions you can choose from. So we'll try 785 times sine of 38.5 and 785 times cosine of 38.5. And then when you crunch both of those, you get for the sine term 489, and for the cosine term you get 614. Now, I'm sure you've spent plenty of time in math class doing probably memorizing some kind of way not to get these mixed up. I'm going to show you the way that I do it. So in this case, if it's 38.5 degrees west of north, take a look at it. Is it going more north or more west? Well, the angle is less than 45 degrees, so it's going much more, slightly more north than it is west. Do you see that? How this vector would have to be bigger, since it's not like it's bent way over here. It's closer, it's going more north than west. So if you look at these two, without even having to do a whole lot of thought, you can just figure out, okay, well, the bigger one, the 614, is the velocity in the y direction, and the smaller one is the velocity in the x direction. Done. No trig headaches about it, no memorizing some weird thing your math teacher told you. Just kind of use your common sense on which one should be bigger. And if it's 45 degrees, then they're both going to be the same, so it doesn't even matter. So those are your two velocities, 489 and 614. It asks you, how far did it go after 3 hours? Well, that's really easy. For the x direction, so for how far it went west, you just take this number and triple it, right? Because it went 489 kilometers per hour, and it did that for 3 of those hours. So that gives you, just a second, got a cheap calculator here, it takes a sec. So 1467, and then in the north direction, it's the same drill. You just multiply it by 3. So what's that? 1842, I think, trying to do it in my head. And that's going to be in kilometers for both. Sorry, kind of sloppy. I'm trying to rush through this. And that does the trick. So every time you see an angle in a problem, every time something is happening at an angle, always, always, always break it down into x's and y's. It simplifies it, because now you just have how fast it's traveling one way and how fast it's traveling another way. And it's sort of like just going right back to what we just did before in class.